In many homes, water use is part of background routine. Faucets turn on during cooking, cleaning, and laundry. Garden hoses run in the evening. Ice trays refill without much thought. Most of the time, this happens through fixed infrastructure, municipal lines, private wells, or stored supply systems. When those systems work normally, attention stays on other tasks. Water remains a utility rather than a focus. Effort tends to increase when supply becomes less predictable. Pumps need maintenance. Filters require replacement. Storage containers must be cleaned and rotated. Outdoor collection methods depend on weather timing. In dry periods, routines shift. Showers shorten. Outdoor watering changes. Extra time goes into monitoring levels, checking flow rates, or arranging deliveries. These adjustments do not always feel dramatic. They accumulate quietly through small tasks repeated daily. Carrying containers, watching gauges, planning use. The weight comes from repetition rather than urgency. Over time, the process of simply maintaining access can take more attention than expected, especially when supply relies on a single source, such as a well, delivery schedule, or rainfall pattern. Joseph's Well is presented as a digital, instructional product. It is not a physical device shipped to a location. Instead, it consists of guides that explain how to assemble a water-generating setup using commonly available components. The material is delivered in a structured format that includes video demonstrations, written plans, and diagrams. The core content shows how to build a system designed to extract moisture from the air through condensation-based processes. It outlines parts lists, assembly order, wiring layout, and filtration flow. The format focuses on household-scale construction rather than industrial equipment. It does not function as a drilling service, a plumbing installation, or a municipal connection replacement. The product is also not presented as emergency response equipment supplied by an agency. It does not include on-site support, physical installation, or customized engineering. Its structure is informational. The responsibility for sourcing materials, building, and operating remains with the user. The program sits in the category of DIY technical instruction rather than finished hardware. In practice, interaction with this format begins with review. The user watches the step-by-step build process and studies the diagrams. After that, time shifts toward gathering parts such as coils, fans, power components, housings, and basic filtration elements. These items are typically sourced through hardware suppliers or general retailers. Assembly requires workspace, basic tools, and careful following of instructions. Wiring and component placement are shown visually in the guide. The process resembles other small appliance-style builds rather than large construction. Once assembled, the system is positioned in a location where airflow and electrical supply are available, either from standard outlets or a small independent power setup if chosen. Operation is described as continuous rather than occasional. The device runs to draw in air, cool it, and collect condensed moisture into a storage container. Routine involvement includes checking filters, emptying or redirecting collected water, and keeping airflow paths unobstructed. The pattern becomes one of periodic observation and light maintenance rather than constant handling. Environmental conditions influence performance rhythm. Humidity levels, temperature, and airflow affect how much condensation forms over time. The guide addresses placement considerations, but does not remove the need for monitoring. Use becomes part of household systems management, similar in cadence to maintaining a dehumidifier or air handling appliance. This format simplifies certain aspects of access. It shifts part of the supply process from external delivery or underground sources to atmospheric moisture. It also concentrates information that would otherwise require research across multiple technical topics, placing build steps into one sequence. At the same time, several elements remain open. The system depends on ambient air conditions, which vary by region and season. Electrical supply, whether grid-based or alternative, is still required. Component durability cleaning schedules, and long-term performance depend on build accuracy and maintenance habits. Because the product is instructional, outcomes are tied to how closely the directions are followed and how parts are selected. It does not remove the need for safe electrical practices, proper filtration handling, or awareness of local regulations regarding water systems. The guide presents a pathway, but execution details remain in the hands of the builder. Compared to large commercial water machines, this approach reduces upfront equipment purchase but increases hands-on involvement during setup. Compared to passive storage methods, it introduces mechanical elements that require oversight. The trade-off sits between independence in assembly and responsibility for operation. Joseph's Well occupies a place between conventional infrastructure and pre-built specialty equipment. It aligns with other DIY instructional programs that translate technical concepts into step-by-step projects for home environments. Its value cannot be fully assessed from description alone because clarity of instruction, pacing of demonstration, and detail of diagrams affect how usable the material feels. Some aspects only become clear through direct review of the guides. The precision of measurements, troubleshooting coverage, and visual angles and demonstrations influence how easily a viewer can replicate the build. Written descriptions outline structure, but the experience of working through the material determines how the format functions in practice. As with other informational products, the content itself is the primary deliverable. Understanding of the system, its assembly flow, and its operational rhythm depends on going through the material and seeing how each section connects to the next. The format explains a method and shows one way to arrange components, while leaving the broader evaluation of suitability to individual circumstances and inspection of the instructions themselves.